Yo, what's up, YouTube? It's Cracky Tumbine. And Twitch. Twitch chat is on. Still comes here. Oh, fucking yeah. Hell yeah. I have a chemical calculation presentation I have to do today. And I got 1 hour-ish to prepare. I got this. I gotta look it up. What I gotta do. I remember it's a question based on equivalence point. Should be good. Oh, oh. Mm. So it's question number 78. I remember this correctly. I should be having. Should I check? I think it's good to check. Um, yes, 788008. Oh. Like, ooh, how do you do with the neutralization equation? Moles of HCl equals moles of KOH. Calculate the moles of HCl. Number of FCl equals molality of HCl into volume. Molality, concentration, it's all the same. Equate moles of KOH needed. Number of moles of KOH Calculate the volume of KOH required. Volume of KOH is number of moles of KOH by molality. Oxide. Let's see what GPT has to say. Oh, it's better first I read the question. 25 milliliters of 0.063 moles per liter solution of hydrochloric acid are titrated with 0.1045 moles per liter potassium hydroxide solution. Calculate the pH of the solution after addition of 5, 10, 15, 20 milliliters of potassium hydroxide. Calculate the volume of potassium hydroxide solution that has to be added to reach the equivalence point of titration. The potassium hydroxide solution was added to another hydrochloric acid solution with a known concentration after addition of 13.75 milliliters. Potassium hydroxide solution at a pH of 7 is obtained. Calculate the concentration of the hydrochloric acid solution. Okay. Potassium hydroxide solution was added to another hydrochloric acid solution with unknown concentration after addition of 13.75 milliliters of. Okay. So mm, in exercise 78, we continue the strong acid beta. We can analyze how pH changes as we add increasing volume of potassium hydroxide to a fixed volume of hydrochloric acid. No, why did you still do this part A? No. Mm. who is the conversion of concentration. Oh, I did this question already. I could look into my stuff. Oh, whoa, where's 70? I'm cooked at the. I'll write a new one. I'll write a new one. It's okay. It's okay. I'll write a new one. The last one's crazy. Oh, bro, what are here? $78. Calculate the volume of potassium hydroxide solution that has to be added to reach the equivalence point of the titration. The volume of potassium hydroxide needed to be added to reach equivalence point. So the equivalence point is reached after adding 15.07 milliliters. I would rather start with what is equivalence point. Potassium hydroxide solution was added to another hydrochloric acid solution with unknown concentration after addition of 13.75 milliliters of potassium hydroxide solution. A pH of 7 was obtained. Calculate the concentration of hydrochloric acid. Concentration of the hydrochloric acid solution. So let's start with the titration. What is equivalence? The equivalence point in the stage in titration where the amount of acid equals the amount of base added, meaning they have completely reacted with each other in 1:1 molar ratio if the reaction is balanced that way. You're titrating hydrochloric acid, a strong monoprotic acid, a strong monoprotic base. Neutralization reaction. This is a 1:1 reaction. 1 mole of HCl reacts with 1 mole of KOH. What happens at the equivalence point? All the HCl has been exactly neutralized by KOH. There is no excess HCl. Solution contains only neutral salt and water. Since both the acid and base are strong, the pH at this point is exactly 7. Equivalence point. The stage is a stage in titration in which the amount or moles of acid equals moles of base. They have completely reacted with each other in a 1:1 ratio, molar ratio. Therefore, the concentration of OH minus and H plus produced would be equal. So the concentration. Uh, yeah, H plus acid. So the concentration of H plus and OH minus would be equal that they combine to form water. Therefore, the H plus and OH minus from the acid and base would be neutralized to form water. And a neutral salt, KCl, which makes the pH 7 at this point, at the equivalence point. Oh, okay. I don't think it's a good idea to write about moles of OH. So what else? Whoa. In this case, both the acid and base are strong, which results in a pH of 7 with a neutral salt and water as part of the solution. I asked for 78. Use stoichiometry. Uh, Balanced equation. HCl plus KOH gives KCl plus H2O. Mm, that's the balanced equation. 1:1 mole ratio. One mole HCl, one mole KOH gives one mole KCl plus one mole H2O. Okay, so that's the balance equation. So from the last part, we could see that the pH is changing significantly from 15 milliliters of potassium hydroxide added to 20. It changes from 3.73 to 12. So the equivalence point, or pH being 7, is between these two numbers. 15.07, yeah. At equivalence point, NaHCl, number of moles of HCl equals number of moles of KOH. So volume of KOH equals number of moles of KOH by what is this? Manual. I'll message you, man. Number of moles of KOH by concentration of KOH. Concentration of KOH were okay. Where the concentration of KOH is from the question, it's 10.45 into 10 raised to minus 2. Just these both are liters. Mole per liter. Mole per liter. Where's my fucking calculator? 1.575 divided by 10 point, okay. 15.07 into 10 raised to minus 2 liters. Point. That's pretty big. That's pretty big. Oh, come on. So it's 15.07 into 10 raised to minus 3 liters, which implies 15.07 milliliters. Now, what is the volume of HCl? Oh shit, I don't know. Volume of HCl. I mean, you could find it by doing the calculations. Number of moles of HCl by concentration. Oh, yeah. There is volume, 25 milliliters. Das ist the volume. Find the So part B. Wish, 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 wish. 25. Oh, okay. That's about right. Uh, the potassium hydroxide solution was added to another hydrochloric acid solution with unknown concentration. pH of 7 was obtained. So the part 2 question is also based on equivalence point. It's about 10 milliliters of HCl with X moles of concentration plus 13.75 milliliters of potassium hydroxide, giving, yo, Masonic, what's up, man? Giving 12, no, 14 pH, no, 7. pH of 7. Yo, what's up? What are you up to, man? I I have a presentation in about 1 hour after to the class. So I was looking into what to check, what to do. Gotta do question number 78. Volume, okay. I'm working on my YouTube branding. Okay. What would that be? Volume of HCl, volume of KOH, concentration of KOH, point. The concentration was given in the last part. Yeah. Yeah. I'm looking at making merch, okay. With the Masonic 12 merch, okay. Cool. How do you start working on those? Where do you get the merch? Contact sellers. Concentration. Therefore, moles of HCl. How do you start? Which process of making the merch are you at right now? Uh, I have a website for business branding, and one of the things they do is make merch if you pay for it. Designing, okay. Oh, it's they make merch for you, okay. Interesting. That's actually so you designed your own merch from this website? Yeah, and they'll make it and send it to me if I pay. Okay. What type of merch? What's written on these? What is it? Is it a T-shirt, backpack? I mean, when I say merch, the first thing that comes to my mind is T-shirt. Is it a T-shirt? Uh, Either a T-shirt or a long sleeve. Hmm. What's written as design? Is it like your name or Hmm, just my logo? Okay, that's cool. You have to keep it simple. What is your logo exactly? Okay, it's with the controller. Okay. The more you try to keep it simple, it's gonna look. I don't know. The more simple it looks, the more cool it looks. For me, that's what I think. Okay. Number of moles of KOH. Volume 13.75 into 10 raised to minus 3. I'm gonna do something like a logo on the chest and one on the wrist. Okay, the one on the wrist. That's if it's a long sleeve. Okay, one on the wrist. That's I ain't never seen any long sleeve T-shirt with stuff on the wrist. That's pretty good. Concentration. I believe it's on the first. Yep. So it's 14.36 moles. Now that think about merch, I'm also, if I could get a T-shirt with my logo, I would be happy to wear that. 14.36. What the? On the website, I use a T-shirt is only 13 bucks, and you customize the whole thing. Okay. I mean, if you could let me know the website, I could check it out when I get time. Okay. Mm-hmm. ChatGPT stop working? Come on. Okay, it's A plus B. 1.43. It's 1.43. (1.437 into 10 raised to minus 3). Which is exactly equal to number of moles of HCl. Now I have to find the concentration, right? If you got a concentration, number by volume. Concentration of HCl equals number of moles of HCl by volume of HCl, which equals 1.437 into 10 raised to minus 3 by 10 into 10 raised to minus 3, which equals 14.37 into 10 raised to minus 2 moles per liter. Ultimate AI logo maker. Need to look into it. So, yeah, that's it. That's the question. So, well, how do I start? What do I say? So, for the second question, we're asked to For the second question, we are asked to find the volume of KOH needed, potassium hydroxide needed to reach equivalence point of titration with HCl. That means the moles of KOH, KOH would be equal to moles of HCl, and the pH of the solution would be. And when this is achieved, the pH of the solution would be 7. This is only specific for this case where both the acid and base are actually strong. So the balanced equation would be 1 mole of HCl reacts with 1 mole of KOH, gives 1 mole of neutral salt of potassium chloride and water. From the previous question, we could see that, yeah, from the previous question, we could see that the pH between 15 milliliters and 20 milliliters of potassium hydroxide changes significantly. So changes significantly. So bro, the word significantly, I hate it. Changes drastically. So the equivalence point should be between these two volumes, and yeah, the number of moles of HCl is moles at equivalence point. Both these number of moles of both acid and base would be equal. So the volume of the base, volume of KOH, is the number of moles of KOH by concentration of KOH, which is 1.575 into 10 raised to minus 3 by 10.45 into 10 raised to minus 2, which gives 15.07 into 10 raised to minus 3 liters, or 15.07 milliliters. At this point, the pH of the solution would be equal. At this point, the concentration of HCl and KOH is equal. That's what this at 15 milliliters of uh, 15 milliliters of this solution. Now 10 milliliters of. For the next question, the HCl. Next question is also based on equivalence point, but the concentration of HCl solution is unknown, but 10 milliliters of unknown concentration of HCl and 13.75 milliliters of pre-concentration of KOH gives a pH of 7. So they both are at equivalence point. Should we have to take water autoprotolization? Pro proto I forgot the auto self ionization. No, we do not need to account for water's autoprotolysis in this case because it's have negligible effect under conditions of strong acid and base titration. Okay, so strong acid and base titration. Oh man, why do I feel so sleepy? I took a shower. I ate some oats. Should be good. I should be good, man. So yeah, so for the next question, it's the same acid and base, but the concentration of HCl is unknown. 10 milliliters of unknown concentration of HCl with 13.75 milliliters of the previous concentration of KOH solution, adding together to form adding together, which results in a pH of 7. That means these are at equivalence point. Therefore, the moles of KOH and moles of HCl is equal. The moles of KOH, number of moles of KOH is volume into concentration, which is 13.75 into 7, which gives 1.437 into 10 raised to minus 3 moles, which is the same moles of HCl. Concentration of HCl is number of moles of HCl by volume of HCl, which is 14.37 to 10 raised to minus 2 moles per liter. Moles per liter. Moles per liter. Strong acid, strong base pH of 7. Weak acid, strong base pH less than 7. Greater than 7. Strong acid, weak base pH less than 7. It's a bit acidic. What? Why am I getting tired? Could you give me a what it's not even charging? Idiot. 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 Which other device is connecting to the headphones? I don't get it. I don't get it. I don't get it. I don't get it, man. The computer is not. Can I believe? Maybe it's the computer.